In the vast and silent void of space, our solar system spins quietly around an ordinary star. We live on a small blue planet, vibrant, warm, teeming with life, a jewel in the dark. But out there, beyond the warmth of the sun, beyond the familiar comfort of the inner planets, lie colder, stranger worlds. Some are giants made of gas, spinning with ferocious storms. Others are rocky remnants from the solar system's birth. And then there are the moons, dozens of them, circling these planets like dancers around ancient titans. Among these moons, one stands apart. One icy world may hold answers to one of humanity's oldest, deepest questions. Are we alone? That moon is Europa. Europa orbits Jupiter, the largest planet in our solar system, a swirling gas giant more massive than all the other planets combined. Jupiter is a colossus with a magnetic field so strong it generates radiation belts far deadlier than anything we face on Earth. Orbiting this behemoth, Europa appears almost delicate, a frozen, glimmering world the size of our moon. From a distance, Europa looks peaceful. Its surface is smooth and bright, reflecting sunlight like freshly fallen snow. But a closer look reveals something strange, a chaotic web of dark lines and jagged ridges, like cracks in ancient glass. These aren't scars from impact or erosion. They're tectonic, dynamic, alive with motion. Europa's surface tells a story, not of stillness, but of change. So what drives this motion? Why does a world so far from the sun seem geologically active? The answer lies in gravity, the relentless pull of Jupiter. Europa is locked in an elliptical orbit, and as it moves, the gravity of Jupiter, along with the tug of neighboring moons like Io and Ganymede, stretches and compresses Europa's interior. This constant squeezing generates heat through a process known as tidal flexing. That heat is what keeps Europa from freezing solid. It warms the moon from within. It melts the underside of the icy crust. And deep below the frozen surface, it sustains a secret ocean. Yes, Europa has water. Not frozen, not vapor, but liquid. Beneath the ice, hidden from sight, is an entire global ocean. A vast, dark sea enveloping the moon, possibly 40 to 100 miles deep. That's deeper than any ocean on Earth, and the volume is staggering. By some estimates, Europa contains more than twice the water of all Earth's oceans combined. Let that sink in. On a tiny moon, nearly 400 million miles from the sun, there may be more water than anywhere else we've ever found. This isn't science fiction. This is the leading scientific consensus, supported by decades of data from missions like Voyager, Galileo, and the Hubble Space Telescope. The ocean is real, and where there is liquid water, sustained over geological time, there is a possibility of life. On Earth, life needs three basic ingredients: liquid water, a source of energy, and the right chemistry: carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. We once thought life could only exist where sunlight reached. But then we discovered hydrothermal vents at the bottom of Earth's oceans, ecosystems powered by heat and chemicals, not sunlight. Whole communities of organisms, thriving in darkness, feeding on mineral-rich water pouring from beneath the seafloor. The implication was stunning. Life doesn't need sunlight. It needs energy and chemistry. So if Europa has water, and we know it does, and if it has heat, which tidal flexing provides, could it also have the chemistry of life? Could Europa's ocean floor host hydrothermal vents, like Earth's? Could it harbor microbial life? Or something more complex? We don't know. Not yet. But the conditions are there. And that makes Europa one of the most promising places in our solar system to search for extraterrestrial life. And then came the plumes. In 2012, the Hubble Space Telescope detected something astonishing. What appeared to be massive jets of water vapor erupting from Europa's south pole, reaching over 100 miles into space. These geyser-like plumes might be venting directly from the subsurface ocean, escaping through cracks in the ice. If that's true, it changes everything. It means we don't need to drill through 10 miles of ice to reach the ocean. The ocean may be coming to us, spraying into space, carrying its secrets with it. Since that discovery, more evidence has mounted. Instruments aboard Galileo, decades ago, recorded magnetic anomalies and plasma shifts as the probe passed near Europa. We now think it may have flown straight through one of those plumes, unknowingly sampling an alien ocean in 1997. But this time, we'll be ready. NASA's Europa Clipper mission is set to launch soon. It won't land, but it will orbit Jupiter and perform dozens of close flybys of Europa. Each pass will be packed with instruments: radar to probe beneath the ice, spectrometers to analyze surface materials, cameras to map the terrain, and particle detectors to sample any plumes it encounters. Clipper's job is not to find life, but to determine whether Europa could support life. It will search for organic molecules. It will measure ice thickness. It will analyze the composition of the ocean and the potential for chemical energy. It will be our most detailed look yet at this mysterious moon, and it may help us answer one of the greatest questions ever asked. But Europa guards its secrets closely. Exploring it won't be easy. The radiation environment around Jupiter is brutal, 1,800 times stronger than what we experience on Earth. Any spacecraft that approaches must be hardened against damage. Every orbit is a race against time. And landing on Europa? That's a dream for the future. A future that may involve autonomous drills, robotic submarines, and artificial intelligence navigating the dark seas of another world. It's science fiction for now, but the path begins with Europa Clipper, with observation, with measurement, with careful listening. Europa may be 390 million miles away, but we are closing the distance. The search for life beyond Earth is more than a scientific quest. It is a mirror, a reflection of our curiosity, our humility, and our longing to understand who we are. If we find life in Europa's ocean, even the simplest microbe, it will mean we are not unique. It will mean life can emerge wherever conditions are right. That biology is not a miracle, but a pattern. And if we find nothing, that, too, is an answer. It will mean that even in oceans of water, life might still be rare, fragile, precious, and perhaps exclusive to Earth. Either answer reshapes our understanding of the cosmos and ourselves. Europa is more than a moon. It's a frontier, a cosmic message in a bottle, floating in the dark, waiting to be opened. It has waited for billions of years, its ocean sealed beneath ice, its energy simmering in the deep. And now we are coming. Not with myths and wonder, as the ancient Greeks imagined when they named this moon after a goddess, but with science, with spacecraft, with reason and relentless curiosity. Europa hides secrets, ancient ones, and soon we will begin to uncover them. In doing so, we may not just learn about a distant world. We may learn about the nature of life, about the resilience of biology, about what it truly means to be alive in a universe filled with silence, stars, and the potential for something more. Europa is cold, distant, silent, but it is not empty, and it will not stay silent forever.